Hey, good afternoon, pirates. It's Mr. Anderson back with you. We're going to look at a CPM lesson from the appendix A.1.5, talking all about simplification today, and we're going to use algebra tiles to touch on and grasp that algebraic component of how we use manipulatives to do the symbolic part of the simplification. You're going to want something to write on, maybe a set of notes. You're going to want a tab open, maybe to our Schoology course, and maybe to A.1.5, so you can do some of the manipulating. Okay. I got a leading question here that kind of leads you. We certainly have a very obvious thing. Which one's bigger there? 58, or 62. But when it gets into situations where we're dealing with symbols, it's a little bit more abstract. Okay, we're going to work in a situation where we've got some algebra tiles helping us out. And here's what I'm going to ask us to do. I'm going to ask us to start with number 48 here in A.1.5, and I'm going to kind of bypass letter A and focus on letter B. And you can click the link in the problem if you like, and you can find the expression mat. But what I'm going to ask you to do is I'm going to ask you to pause your video right now, and I'm going to ask you to try to build B. All right, so one more time. Pause your video and try to build this on the expression mat. Now, there's more than one way to do it. Okay, so if you build it and it looks different than mine, that's okay. But let's see how we do it when we get our answer. We'll see if they're comparable. Okay, so pause your video. 3, 2, 1. Go ahead and pause and try to build B. Okay, I'm right back with you. I built B. Did you build B? Let's see how you did. We have negative, or the opposite of negative 2x plus 6 plus 3x. The obvious part over here is I've got my plus 3x, and then I've got negative 2x plus 6. That part maybe looks pretty obvious, but why the heck is it down here? Well, that's because the whole thing is wrapped in those parentheses, and it's made negative, or we're taking the opposite. So what we're going to do now is we're going to go ahead and try to find a different way, or an alternate way, to represent this exact same expression. So I'm going to take and I'm going to try to make it as easy as possible. And the way that I do that is I take and drag everything to the top, switch the sign, and then do any combining of like terms, do any eliminating of opposites that I can. So I'm just going to take this, I'm going to bring it over here. I'm going to take these, I'm going to bring them up. Now right now it doesn't necessarily look all simplified, but when I brought them up, remember, I should have switched the sides. Oh my goodness, this one doesn't want to turn negative. Holy cow, I have a busted algebra tile. There we go. All right, and when I do so, now I can combine my like terms. I can slide that over there. Now it's very clear that I've got 1, 2, 3, 4, 5 x's and negative 6, and that's something that I can write maybe pretty easily. 5x minus 6, and does that check out? Of course, if I distribute that negative throughout, I get a positive 2x minus 6 plus 3x, and I think you all see that if I take the 2x and the 3x, I can combine them and I can get this 5x here. All right, that's kind of our goal today, is to be using those algebra tiles to do that simplification. We've got another comparison here, and there's some algebra mats, or algebra expression mats, on the top of 49 there, and you can see that we've got 3 tiles that are negative up top here. That value is negative 3. We've got 2 that are down here in a negative space. That value is negative 2. But which one's bigger? We're going to talk now about how we can use the expression mats and the algebra tiles to maybe make that decision, right? Because we're going to be able to see by dragging everything to the top and following these rules that we're kind of slowly laying out here, how easy this can be. So here we go. It says build the expression comparison mat shown at the right. We're not going to have to build it because, golly gee, they have that E tool for us. So we're going to go to the book, and we are going to click the link in A49. Oh man, that sure is nice to have that there. And now it is built for us. And they want to know which one's bigger. Okay, well right now I'm going to be honest, I don't have a clue. I've got to do some simplification. We're going to follow those, what's it called? We're going to follow those legal rules, and we're going to see which one is bigger. And I'm going to start by bringing everything to the top and changing the sign. Okay? And right now, you may not, you may not have an idea, but we can do something else to simplify this. We can get rid of opposite pairs. So I'll take a positive and a negative and get rid of them. I'll take a positive and a negative and I'll get rid of them. Whoops, that was one too many there. A positive and a negative and I'll get rid of them. Well, I can do it over here on the right side too. I take a positive and a negative and I get rid of them. I can take a positive and a negative and I can get rid of them. One more time, a positive and a negative, and I can get rid of them. Now, it might be clearing which one might be bigger, but there's one more simplification step I can do. I've got kind of two sides. I'm not going to call this an equation yet, even though some of you might see that's where we're headed. I've got two sides, and if I get rid of things that match from the left and the right, some of you guys know that's a legal move, right? So I've got an X over here, I've got an X over here. I'm going to take the same from both sides. Now, which one's bigger? Over on the left-hand side, I've got -3. Over on the right-hand side, I've got +1. And what I can do is I can call this thing -3, I can call this thing +1, and I can say that the left is smaller than the right, or the right is bigger than the left. Remember, the alligator eats the bigger number. We've got a method that is going to allow us to simplify both sides, and I'm kind of informally laying it out here. All right. We're going to go ahead and drag everything to the top of that expression mat, and we're going to simplify by switching the sign. Then we're going to eliminate opposite pairs, all right, or 0 pairs maybe, okay? And then we're going to cancel things from the left-hand side only if they're cancelable from the right-hand side. We're going to take the same thing from each side, okay? And that's going to work out really, really well. Those are some of our algebraic rules that we're physically manifesting in this expression mat piece. We already kind of talked about B. Hey, which one do you think is greater? I think it's probably pretty clear after looking at this that the right-hand side is the larger side, okay? In 50, we've got another problem, and we've got a layout here, and I'm going to encourage you to read this with me. Oh, my Notability app just went down on me. I got to reopen this. I'll go to the book while that's opening, and we'll read it from there. All right, let's check out number 50. It says, as Carl simplified some algebraic expressions, he recorded his work on the diagram below. All right, and Carl, we're to explain in writing what he did to each expression mat, and then to get from the left to the right. Okay, we're not going to necessarily do that in writing. I'll walk you through a couple of these, and we'll do it verbally, okay? And I do have my iPad working again, so let's go ahead and check it out here. What has he got going on over here on the left-hand side? Well, check this out. He's got some opposite pairs circled, just like we did. We got some opposite pairs circled. He's canceling those things out. So in part A, right here, he is canceling those 0 pairs, or canceling opposite pairs, okay? What about in part B? What did he do here? You guys have seen me do this. He's taking these things and he's dragging them up. And now notice, after that action, the tiles changed a little bit, didn't they? He's taking them, dragging them from top to bottom, and he's flipping. Okay? That's what's happening in B. That's our second legal move. And now he's got our third legal move being represented in C. And you can see he's got an X tile that he's taken off the left-hand side, an X tile taken off the right-hand side, and he's dragging and removing those from both sides and eliminating. Some of you guys like to use the terminology or the phrases, he's canceling from both sides, and that's going to work. And the reason that does is because eventually when we start to drag across the middle of that expression mat, we'll also flip the sign, and you'll see that creates another 0 pair. Getting a little ahead of myself there, but that's ultimately where we're headed. Okay, we've got what's it called? A problem here. We've got those legal simplification steps that we just talked about, and we're going to go ahead and we are going to determine the which is greater part. I'm going to pause the video, and actually, I don't know. Do I have one of these? Do I have the E tool here in number 51? I might. Do they have it built for me? Nope, they don't. They just have the resource page. So here's what I'm going to ask you guys to do. I'm going to ask you to pause it, and then I'm going to ask you to build A. All right, I paused my video. I built A. Hopefully you did as well. Check it out with me, though. Let's try to do some of these legal moves, and I'll do them in order and do some canceling. This is 51A, and it is built pretty, gosh darn. You know what? I just realized I'm missing another tile. Oh, I thought I had it perfectly. I realize as I'm looking at my work here that I'm missing this tile right there. Let me make that negative. Okay, now we're asked the question, hey, which one of these things is greater? I hope you guys are willing to start like I'm willing to start. Let's take everything from the bottom. Let's drag it up to the top. Doesn't matter where you put it. Put it somewhere up on the top. Keep it on the same side. But just flip the signs. All right. Got to turn that sign. There we go. And now, once that happens, you might have a little clearer idea of which one's greater, but you may still not know for sure. So let's go ahead and start to put zero pairs together, and let's do some canceling. There's a zero pair. It's gone. This is going to be a zero pair. It's going to be gone. This is going to be a zero pair. Hey, that's gone. And one more time, zero pair. That's gone. Now, this is looking pretty clean on the left-hand side. It's 3. Let's check out the right-hand side. Zero pair. Okay. Zero pair, all right, gone. Zero pair, all right, gone. Hey, I think we just ran into a situation where we can't really answer that question, right? The question is which is greater, and we're in a situation where neither is greater. I think we're in a situation here, folks, where you guys know this. Maybe that's a little foresight into where we're headed. Right? We're not dealing with a situation of which is greater. We're dealing with a situation where these two things are equal. Okay? A little bit of review preview. I know that went pretty quick. I hope you're going to use the algebra tiles to help facilitate some of this review preview. But this is going to be the last review preview assignment for week 3. It's going to be 53 to 58. You can see it there. Go ahead and start some of those problems. Don't forget to use your homework help. You can definitely use your notes. And folks, it's going to be a good idea to try to use these algebra tiles to help you with some of these problems. Thanks for watching. Have a great day.